today we are looking at how to prove that log x to the base a plus log y to the base a equals log xy to the base a. Okay, so here y is the sum of this given as this. That's exactly what it means. Y. So what we do is we take them individually. We take the first term, second term, then after that we add them. Right? So let's represent the first term with any variable of our choice. We can also, and again, represent the second term with any variable of our choice. You can choose any variable that you like. So here, take that. Let's say it should be equal to Q, right? Okay. So that we can take the second part, the second term. That's a P. So let log x to the base a to be equal to Q, and log y to the base a to be equal to P. Now at this point, let's convert each of them to indices. Okay, as we stated earlier, here the base is the same base in indices. The answer here becomes what? The exponent in indices. Then the value here becomes the answer in indices. So here we have the base, which is a, exponent what? Q. The answer becomes the exponent, and this one should be equal to the value. And over here, the same approach. The base is still a, exponent over here is p, and this one should be equal to what? Y. Now, we can consider this one to be equation 1. And this one to be equation 2. Okay, so this we have equation 1, equation 2. Multiply equation 1 and 2. We have to multiply equation 1 and 2. So here what we do is we multiply corresponding values. So a exponent q multiplies a exponent p, then the x over here multiply the y. That's the corresponding values, right? So we have a, so you can see that we have a exponent q multiplying a exponent p, and this is equals to x multiplying y, multiplying corresponding values. So here you can see that in terms of indices, what we learned earlier, we said when the bases are the same, what happens? Okay, so we take one of the base and add the exponent. So we take one of the base here, then the exponents are what? Q plus P. We add the exponent, and this should be equal to x, y. At this point, we can take log of both sides. Log of both sides. So we are going to take log to what? Base A. Log to base A of both sides. So we are going to take log to base A So that's what we have. Log to the base a exponent q plus p equals log to the base a xy, as we stated earlier. So at this point, q and p go back because it is an exponent, right? So that's what we have. So we send this one to the back of the log to multiply it. And this will be equal to log xy to the base a. So here, what is log a to the base a? Okay, 1. So we are going to have so the whole of this becomes 1. So you multiply them, you are going to have equals to. Now you see that we have Q plus P. Now initially we said P and Q are representing something. We introduced them to the system, and we said log x to the base a equals Q, right? Then log y to the base a equals P. So at this point, we can introduce them back. Let's bring them back to take their rightful positions, right? So Q is representing log x to the base a. So we put them back. Okay, then plus, you put your plus there. P, we have log y to the base a. So we have P to P representing this, the whole of this. So let's introduce it back. And this one should be equal to, we have log xy to the base a. Okay, so you see that we have log x to the base a plus log y to the base a equals log xy to the base a as it was given to us. So this means that it has been, or this shows that it has been proven. And that's what we have, and I hope you are okay with it and there's no problem again.